Okay, so these are some terms that we'll use a little bit later. This is a little concept here. Okay, so let's go back to describing the distributions that we have on the wall over there. So let's describe the sampling distributions. We had the mean heights of women. So we're just going to describe a sampling distribution for a mean. Okay. So far from the wall, what do you see as the shape of this sampling distribution? What are you calling this one? We can say this one is approximately normal. It actually will be normal because if we got the whole sampling distribution, we're taking it from a whole population that's normally distributed. But approximately normal is going to be good enough for what we're doing. And I say approximately normal because most times you don't ever want to say normal without the word approximately around it. You'll get yourself into trouble. So stick with whenever you say normal, saying approximately normal, and you'll be okay. Yes, sir? Right, exactly. Right, right, right. So we use approximate because we're not in we're out of theory. Everything we do is applications. So, yes, ma'am? Right, right. So approximately normal, I think of these low tails and the high, I think of that as being approximately normal. What if I'm just it's not exactly normal because maybe this section right here is kind of off. Yeah, yeah. We'll look at a distribution that is pretty close to a normal distribution, and you wouldn't be able to tell it from a normal distribution, but it isn't a normal distribution. It's going to be a t distribution. So we'll look at some that are pretty close to normal, but they're not. But they look a lot like it. Yes? Because we're going to use calculations on a normal distribution, so we'd like for it to be close to normal. Normal as opposed to there's no skew, there's no bimodality in it. It's normal is symmetric, and it has a particular equation that we went through before that I told you never needed to memorize. But if you were going to say it was exactly normal, it would have to meet that equation. Yeah. Okay. Center. Better be the mean of the parameter. The mean of the parameter for our female heights was 64.5. The mean of our sampling distribution better be 64.5 also. And our spread, what's the spread look like compared to the population spread? So take a look at the sampling distribution and compare that to the population. What do you think about the spreads? The sampling distribution is the one up towards the front of the classroom. So what do you think about the spread? Not the shape, the spread. It is less spread out than the population distribution. Okay? So it has less variability. Okay? Alright, so we are not just going to look at sampling distributions for means. We're also going to look at sampling distributions for proportions. These will be our two basic ones to try to analyze this year. So we're going to make a real quick sampling distribution for a proportion. So I want you to either get out your calculator or get out a die. and we're going to roll the die 5 times. Okay. What proportion of these should be even? Okay. So if I think of rolling a die, and I think of that population, rolling a die, half of that population is going to be even, half that population is going to be odd. The distribution of my population is not going to look like the histogram on the board. The distribution of that population is going to be that 50% of them are going to be even and 50% of them are going to be odd. Okay, so that's what my population distribution looks like. But let's see what the sampling distribution is going to look like for a proportion. So I want you to roll the die, and I want you to tell me, I want you to roll the die 5 times. You can do a randint, 1, 6, 5, and tell me what proportion you see you get as an even number. So you either get 1, 2, 3, 4, or 5 even numbers. I'm sorry, 0. Yeah. And so you need 5. Pardon me? Okay. All right. We're just going to roll down the rows here and give. Pardon me? You are going to roll the die 5 times and tell me what proportion out of those 5s do you get an even number. Oh, I wrote a 4. Thank you. All right. Okay. So, yeah, we're going to get, 29 counts here. And I'm going to put them on a dot plot. We're going to see what these proportions start looking at. So just quickly, get this in your calculator. Randint 1, 6, 5, and tell me how many even numbers you have. Sabina. 3. You can't get 6 even numbers if you have rolled the dice only 5 times. How many of those 5 times did you get an even number? Four? Okay. 2. I don't know which way you want to go. Anders, you want to go next? Sunjin? 4. Michael? Huh? 2? Okay. Okay. 2,